All right. Well, if you're watching this video and you were in class today, you will know that we had a very interesting class today. If you were not in class, then you missed a very interesting class today. So we're talking about domain and range. They are extended from the lesson last time. So here we go. So domain is this problem says find the range of each function when the domain is -1 and 6. Find the range. All right, so the range is represented by our y value. Hopefully this thing acts right. And it's also called our output. Okay, yeah. All right, the domain is called our x value, and it's called our input. So it says find the range of each function when the domain is -1, 6. So we have, this is the conversation we had in class. So this is a set. Our domain is -1, 6. Now that I know what people are having trouble with, maybe if you watch the video, you won't have too much trouble. So this is our x values, everyone, also called our input values. To find our y values, which is also called our output, we put in, y'all see this? Do y'all see this? Input. Do y'all see the word put and then the word in? Y'all see that? So we put in our domain into our, what we will learn soon enough, function or equation, since y'all don't know that terminology yet. And then we get our output. Look, y'all see that? Put out. So we put in our x to put out our y. So when we look here, people were confused because they say that's a Q and that's a P. Well, if we understand what input means, Latrell made this. He asked me, so how do you know what's the difference between whatever? And I was like, Latrell, let's use our math sense. So put in, input, which variable looks like you're going to put in? And Latrell made this connection that this is the put in. And this is the output. This is on the outside. This is on the inside. He made that connection. I was like, there you go, Latrell. Way to make a connection. So that's what we're going to do, everybody. We're going to put in -1 to find out what the output is. And then we're going to put in 6 to find out what the output is, because every domain has a range. Okay? So every domain has a range. X and a Y. Every domain has a range. So there are 2 domains here. So we have 2 domains. That means we're going to find 2 ranges, because that was the big thing today, y'all. Goodness gracious. All right. So -1 is my input. So this is my input. This is my output. Y'all see that? Put in to put out. So Q is equal to 4 times our first input, -1. I don't know, these little dots, they get on my nerves. -1 minus 7. So Q is equal, that's a crazy looking Q, is equal to -4. Y'all know what that dot means. Goodness gracious. Minus 7. So we get Q is equal to -11. This is our first input, -1. This is our first output, -1. So if we were to write an ordered pair, input output, domain range, x, y, our ordered pair would be -1, -11. Okay? Input output, x, y. Domain range, input output. Put in -1, put out -11. And then we do the same thing for 6. Q is equal to 4 times 6 minus 7. 4 times 6 is 24. 24 minus 7 is 17. So our input was 6. Our output was 17. This says find the range. So what would be the range? our range would be -11, 17. That is the range. Okay? You see that? That's the range. This is my range. -11, 17. Excuse me. So for the next problem, it says y equals x squared minus x. So we're gonna, this is my input, IP. Notice we have 2. This is my output, OP. Put in -1. To put out, let's see. So y is equal to -1 squared minus -1. -1 squared minus -1. This is my input. And you can put that in parentheses to help you see it better, but we're saying -1 squared. The reason why I put this in parentheses is because I'm squaring a negative. So I want you to understand this is a negative times a negative, which gives me a positive. So we get 1 double negatives. That means take away a negative. I call these the twins. We make them Siamese by joining them together. So I'm really saying 1 plus 1. 1 plus 1 is 2. So when my input is -1, my output is 2. This time you see your x and your y. X and your y. So the ordered pair would be -1, 2. And then we do that again with 6. So y is equal to 6 squared minus 6. Yeah, I did it right. So 6 squared, I was thinking about the next problem, is equal to 36 minus 6. 36 minus 6 is 30. Range is 30. So my ordered pair would be 6, 30. So my overall range, the range for this problem, would be 230. Okay, that would be my range. Put in -1, put out 2. Put in 6, put out 30. And then we come over here. Wow, I just went totally through that line. Let's see if we can undo. Stop disrespecting that line like that. All right, so OP, IP. So T is equal to 6 times -1 squared. All right, whatever. It's a -1. All right, order operation says square this first. So T is equal to 6 times, really, 1. 6 times 1 is 6. Get your life together. So if I were to write this as an ordered pair, my ordered pair would be -1, 6. Input, output, x, y, domain, range. And then when we come around here, T is equal to 6 times 6 squared. I didn't mean to do that, but it did it anyway. 6 squared is 36. So T is equal to 6 times 36. And 6 times 36 is really 6 times 6 times 6, which is 6 cubed. And since we know our cubes in squares, 216. So if I would write this as an ordered pair, the ordered pair would be 6, 216. So my range for this problem would be 6, 216. Why, you may ask? WHY? Because this is the Y, this is the Y. Domain, 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 range, range. All right, well, I think I can move on to the next set of problems. Great, let's keep it moving. So on the next set of problems, we need to find the domain and the range of these problems as well. So the domain, again, is my x values. My range is my y values. I can get this right. Come on, stop knocking off Hector. Or that's Joe. I said Hector. Why I say Hector? Oh, because I was looking there. All right. Joe had a summer job that pays $7 an hour, and he worked between 15 and 35 hours every week. His weekly salary can be modeled by the equation S is equal to 7H, where S is his weekly salary and H is the number of hours he worked in a week. Describe the domain and the range for this problem using appropriate notation. So this problem relates back to these other problems. We have an equation, right? And we have a domain and we have a range. So we have S is equal to 7H. This is going to be my output. This is going to be my input, which means that this is my X. We're looking at the order pair. And my domain, this means this is my Y and my range. So it says Joe had a summer job that pays $7 an hour. He worked between 15 and 35 hours every week. His weekly salary can be modeled by the equation S is equal to 7H, where S is his weekly salary and H is the number of hours he worked in a week. All right, so our S is the weekly salary. Our H is the number of hours he worked. So when we look at this problem, the H is the domain. So what would be the domain? The domain is the hours. They tell us that he worked between 15 and 35 hours. So my domain, he worked between 15 and 35 hours. So he can't work no less than 15 hours and no more than 35 hours. So the domain is between 15 and 35, greater than or equal to 15, but less than or equal to 35. Then it says in the problem, what would be the range? Well, input, give me my output. So if he worked 15 hours and he makes $7 an hour, the S represents the salary. So we simply say 7 times 15, which will give us our wonderful salary. He cannot, if he works this many hours, he cannot make no less than $105. So we put this here to find this. Okay, so his salary working this much will be between 105, and we do the same thing again. We take the 35 and we multiply it by 7, and it'll be 245. This pen know how to write now. Look at it, trying to be all fancy. Put this here as well, because this is my domain. This is my input. All right. Hector Service Club is raising money by wrapping presents in a mall. The function y equals 3x describes the amount of money in dollars the club will earn for wrapping X presents. They only have enough wrapping paper to wrap 1,000 presents. Describe the domain and range for this problem using appropriate notation. Domain and range for this problem using appropriate notation. So we have an equation, y is equal to 3x. This is my output. This is my input. All right. So when we look at the problem, let's break it down. We know that the y equals 3x describes the amount of money in dollars the club will earn by wrapping X presents. So X represents the presents. Y represents the dollars. And they only have enough paper to wrap 1,000 presents. Hold up. That's my domain. So my domain is restricted to being less than or equal to 1,000. But that cannot be only the case. Because if I'm just less than 1,000, -5 is less than 1,000. I can't have a -5 presents. So I either wrap no more than 1,000 presents, but no less than 0. So either I'm wrapping 0 presents or 1,000 presents. So my domain X is represented by this function. X is between 0, not this function, y'all, this inequality. X is between 0 and 1,000. Well, if that's the case, just like we did last time, everybody, we're going to come over here and we're going to put in our, trying to change the color of my pen. It's up here acting weird. Maybe they don't want me to change the color. We're just going to be red. All right, whatever. We put this in. 0 goes in here. That'll be 0. 1,000 goes in here. That'll be 1,000. 3,000. I heard me about to say 1,000. All right, let's get to the last problem. Well, it's not the last problem. We'll start the next to the last problem because folks were confused, and you know how life is for some of y'all. A taxi company charges $2.50 plus $1.10 for each mile driven. Write an equation to represent the situation. Use this equation to determine how far you can travel if you have $10. What is the minimum amount of money you will spend? All right, so we're not gonna get to the minimum amount stuff, but we're gonna concentrate on the domain and the range. So a taxi company charges $2.50 plus $1.10 for each mile. Write an equation to represent the situation. So my money that I'm being charged, or the dollars that I'm spending, D for dollars, and then I'm spending $1.10 each mile because I don't know that is either. So those are my unknowns. So when I look at this, my dollars that I spend, D, is going to be equal to $2.50 plus the $1.10 per mile. That's supposed to be an M. I'm not going back and erasing that. We know that's supposed to be an M. All right. So when I look at this, I want to find my input and my output. This is my input, IP. This is my output, OP. All right. So they tell me I only have $10. Well, they just told me what? That I have a range that extends up to $10. So 10 is equal to 2.5. I just put 2.5 plus 1.1 M. So what's my range? Well, the amount of money, dollars that I can spend is no more than $10. So D is going to be less than or equal to 10, but greater than or equal to 0. I have $10 to spend. Okay? So now the money I have is 0 to 10. The M for miles that I need to drive. I need to find out what's the max amount of miles I can go with just $10. If I need to find that out, then I need to solve this. So I do subtract 2.5 from both sides. And we get 7.5 is equal to 1.1 M divided by 1.1. And we get M is equal to 6.8. So I can go no more than 6.8 miles. And if we round it to the nearest tenth, it would be 6.8. Whole number would be 7, but we're going to do 6.8. So the miles, I just drifted off. I don't know if y'all caught me there. Sorry. But the miles is going to be between, I can go no miles or I can go 6.8 miles. So M is greater than or equal to 0, but less than or equal to 6.8. Ayana brought up something very interesting that I'm really thinking to consider. She said today in class that, well, if you don't go 0, if you spend $0, well, wouldn't the domain be 2.5 is D is less than, greater than or equal to 2.5 is less than or equal to 10, because if you don't go any miles, you still pay the $2.50. And I told her in the situation where we deal with that, if you don't go anywhere, I guess it's tricky. In this scenario, technically, 2.5 can be the smallest amount that you pay because you don't go any miles. But if you really don't go anywhere, you're not paying a taxi cab anything. You don't pay $2.50 to get in the car. If you don't go anywhere, you will not be charged. So I told her about that, and so I just wanted to talk about that real quick. All right, the video's getting long. This is the last problem, so you should be happy. Maria noticed that various combinations of $1 bills and $5 bills could make $23. Let X represent the number of $5 bills and Y represents the number of $1 bills. What is the domain and range? So we say X is our $5 bills, right? And then Y is our $1 bills. Let's look at this problem. My foot just went to sleep. Goodness gracious. All right, I got to stand. All right, so let X represent the number of $5 bills and Y represent the number of $1 bills. So if I'm not trying to make $23 and X is my $5 bills, can I make $23 with zero $5 bills? Yes. Can I make $23 with a combination of $0 and $1 bills, $5 and $1 bills? Can I make $23 with one $5 bill? Yes. Can I make it with 2? Yes. Can I make it with 3? Yes. Can I make it with 4? Yes. Can I make $23 with 5 $5 bills? No. So what is my domain? 0, 1, 2, 3, 4. Can I write this as an inequality? No. Because an inequality says that I can have anything between. So that means I can have 1.5 $5 bills or 2.8 $5 bills. That is not an appropriate domain for this problem. So we're going to stop here because this is pretty much where we left off in class, because in third block got to the range, but then they were getting confused. So we're going to stop there and we're going to say we're done. I enjoyed teaching. Stop messing up my check. I got some haters on this video. Leave my check alone. What? Trying to get my highlighting on. Thank you. This has been a great production by yours truly. I appreciate you. And, you know, these wonderful growth-minded people watch videos that I spend time trying to make. But I got some of y'all today. Y'all got the point. You better watch these videos.